Hello and welcome back. I'm sure you've all experienced the horror of having to do a simple change on a part and realizing that the input data is a dead geometry like this one. And instead of taking a few minutes, it ends up taking a few hours. Today, we'll learn a few simple tricks when working with dead geometry, and stick with me to the end and you'll find out how to fully reverse engineer a part and bring it back to life. Okay, this one is the first part we're going to study today. This is a sheet metal part. Usually I recommend when working with sheet metal parts to extract one of the surfaces and then work on the surfaces and create the body later. But in this case, we'll show how it's actually easier to work directly on the solid. So let's suppose that for this change, we need to change the angle of this surface. We need to modify the angle of this surface like this. Let's say 5 degrees in this direction. In order to do that, we need to get rid of these radii along our modified surface. So to do that, we're going to use the remove face command. You click on this. It's a command you will find in part body, and it requires faces to remove and faces to keep. We'll only be worried about faces to remove. We need to remove firstly this one. If you select these and click OK, this time it will work. But let's say if we click another one, it will give you an error. Alright, what you need to do in order to properly remove this, you need to go all the way around the loop and remove the entire feature, because presumably that's the way it was done, and that's how you have to do it. That's how you have to remove it. Now you want to remove the outside radius as well, because otherwise the outside surface will end up inside the part, and that's how you end up with 4-dimensional parts, and you don't want that. Alright, so while I select this loop around, I am going to take the time and ask you to subscribe to my channel and like this video if you enjoyed it and you want to see more content. Okay, now we click OK, and we see an error. One thing to note about this operation is that it's really tricky. I have actually done this before on this exact part and it worked. So there it is. I forgot one corner there. Now we click OK. Good, and you see the radius was removed. Now we do the same with this one. Again, we select both of these radii, click OK, and it worked by magic. I tried this before and it actually didn't work. So when selecting same things and doing the exact same operations with this feature, it sometimes works and it sometimes doesn't. So doing the same thing over and over again and expecting different results this time is not actually insane. Okay, so what you need to do in order to change this angle, you need to create a draft angle. This surface and this one. This normally it would have been 5 degrees, but this is already 53 degrees. It's 53 degrees. So you add another 5 degrees and it ends up 58. Okay, you do this change like that. You see that now you have basically a very thick wall here. So now you need to thin that wall with another draft. Sorry, not like that. You need to draft the inner surface as well. This time you put a minus. Okay, there you go. Now you have a different angle. Now you need to recreate the radii. This one was 100 millimeters, if I'm not mistaken. This one is going to be the inside radius plus 1.6, which is the thickness of the part. Now we need to add these ones as well, 30, and the outside radius, which is 31.6. And there you go. That was pretty easy to do. As you can see, this is the new angle, and the original part looked like this. Having to do this with surfaces would have been a lot more challenging, mostly because you would have needed to extend this surface forward a lot. And looking at this, when you have a complicated surface like this that you want to extrapolate, it's very, very likely that you'll have errors and difficulty in doing that. Our next part that we want to modify is this one from our old tutorial. I'm going to show you a really quick trick on this one. What we want to do in this case is increase the height of the part, but as you can see, this wall has an angle. It's not really straight, so you can just extrude it, and it also has a radius on this corner. So in order to increase the height of the part, what we would need to do is first remove the radius, so that way we separate the surface. We want to extend this one, and now you have a command called thick surface, this one, which would be the wrong one to use, because let me show you what happens if you put this, let's say 5 millimeters. You end up with like a little border on the part that just goes straight in one direction. So you don't want that. What you actually want to do is use this one, thickness. You select the surface you want to thicken, select the length, click OK. And this one will just keep the tangency angle to this surface, and won't create a break in the outer and inner surfaces. Now we just add the radii backs. And there you go. For our next trick, I will show you the limitations of this command. So when I try to remove face, let's say I want to do something on this rib, and I want to remove this inner radius. I select this just like we did before and click OK, and it will not work. And I've tried this offline, and no matter how many times I try it just doesn't work. Sometimes you're better off just designing the part from scratch. If you try a different rib, you will most likely get the same or different results. See? So this is not one savior for all command. It will sometimes work, and it will sometimes not work. So for our third and final part, we will go to our trusty metal bracket that we designed in a previous episode. You can find the link in the description if you're interested in how we do this. So this is a sheet metal part, and in order to reconstruct this, I said at the beginning of the video that we will learn how to fully reverse engineer a part and bring it back to life. So this is how we're going to do it. It's not going to be easy, and it's not going to be fast, but what you need to do is create a new geometrical set and think about breaking this part into its core features. Like we do when we're designing it, we have to do the same when we're deconstructing it. So first you start with an extract of the inner surface. You click on extract, any of the surfaces from below is fine, and you click on the tangent continuity propagation hit OK. That creates this extract here. We can go ahead and hide the body. We don't need it anymore. First tip is, how do we plug this hole here? If you would say just use a fill, you would be wrong, because using a fill does this, and you still end up with a break in the surface here, and you don't want that. Doesn't look really professional. So what you want to do is use the extrapolate feature. You select the boundary as the edge. You probably need to reduce this and put curvature here. Okay, and there it goes. Like it never happened. Now we need to create a geometrical set for the features. We create a geometrical set called features, and then you start adding sets for each feature. Let's say top surface, bottom surface, sides, oops, trim, and then we start deconstructing it. First thing first, we need to get rid of these radii and this rib feature here. Like in the solid bodies, you have the remove face, but this time it's the surface version of this command. It's basically identical. What you need to do is click on everything you want to remove. Here we'll start removing firstly this one in the initial step. When you have simple shapes like this, it usually works fine, no issues. Then you remove this one. Now you need to go into the top surface, extract this top surface like this. You can have no propagation this time. And there is the interesting command called untrim. And this will create a kind of like the base surface from which this one is cut. It doesn't really make it that large. Sometimes it does, sometimes it doesn't. What you could do is extrapolate it with point continuity and give it, let's say, 50 millimeters. You can do an offset on this surface to have better control over it. But you can put it 0, so we can change it later if you want. Good, now we're done with the top surface. Let's go to the bottom surface. I will go a little bit faster because basically you do the same thing. You untrim this one to get rid of the edges. You untrim this one. You then extrapolate with point continuity. Now you need to create a... It's not really required, but we'll just leave it like this for now. This one, what we need to do is go to the sides, extract it. We will extract this one as well. And we can go ahead and hide the initial part. Now we have only extracts here. Good. For this one, you can create a line, point to point, like that. You select this base surface as the support, and then you do a sweep with, let's say, you select the line sweep with the draft direction. Let's go with draft direction. Select the profile, select the draft direction, and the angle, which is, I don't know, 10. Maybe it's 15. Maybe it's 20. And then you go with, I don't know, 100. We don't care. This one, the other side then. Oh, sorry. We can probably need to go with 15 the other side as well. The other one, the other side, this one you can actually decompose as well, like this and like this. We will go with point continuity like that. Extrapolate with point continuity, and you recreate this radius, which I suppose was something like around 10 or 20. I don't know. You can add an offset as a control. You can add an offset for this one as a control as well. And we then go ahead and create a different geometrical set, which you call it final or whatever, and you start doing these assemblies for the features. So we have the extrapolate. Sorry, here we just extrapolated the surface, but we could also put an offset as a control. An offset as a control. Good. And then we go to the final, and then we use the shape fillet on the offset. And let's say 6 millimeters. That's really, really good. 6 millimeters. And then we go with 6 millimeters. Have a small error, but we don't care. Or we don't care at the moment. Good. Good, 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 good. That looks perfect. Now for the trim, you can do the same and deconstruct it and whatever. Just to keep this video short, because it's already getting too long, I will just take the exact trim that we have here. Trim line. Do a boundary and just extrude this in set. Like that. Extrude a lot. And we go to the final one and do the final cut. Splitting of this with this. And okay. And we split the wrong side. There you go. Perfect. And now we have our fully parametric part. You then create a new body. You switch to the part design workbench. Thicken this up, and there you go. You have your part. Oh, minus the rib, but just to keep it short, you can watch my other video how to do the rib. And the beauty of this is that you can also go into these offsets, and now you have fully reversed engineered the part, and it's a lot faster than building it from scratch. Let's see if this works. See, you will eventually get some errors. I mean, stuff happens. It's not it doesn't go towards infinity and plus. But that was my video for today. We will probably make a part 2 for this video, since there are a lot of issues coming up when working with the dead geometry. But for today, that's been it. Thank you very much, and please like and subscribe to my channel if you want to see more content like this.